Hi class, welcome to the next section of chapter 1, 1.8. Today we're going to be talking about inequalities. So the deal with inequalities is that they are solved the exact same way that we solve equations. Okay, there's only one difference. So we're still going to be equal to both sides of the inequality, and we're still trying to isolate our unknown, our variable, by undoing PEMDAS. Okay, same exact thing. The only difference is that whenever we have to multiply or divide by a negative sign, that our inequality changes direction. That's the only thing, right? So if we multiply or divide by a negative, our inequality sign switches direction. That's the only difference. Okay, so inequalities have four symbols, four signs, right? There is a strictly less than, strictly greater than, and then we have our inclusions, right? Less than and equal to, greater than or equal to. If our inequality is non-linear, we treat it a little bit differently. We have to zero out the inequality. We can't just try to solve it the way that it stands. We have to zero it out and then talk about when what we have on one side versus the other side is either positive or negative, right? So we zero it out, and then we talk about our simplified form being either positive or negative, because now we are relating it to the value of 0, right? So when it's nonlinear, we're going to zero it out. We're going to solve for the zeros, whether this is through graphing, through factoring, or solving using quadratic formula, or completing the square, or what have you, the other methods we have for solving polynomials at this point. Okay, and then the next thing we're going to do is we're going to identify, if possible, any values that are not in the domain of our equation. Okay. So then the last step is we're going to check the values on the left and the right of the values that we found in 2 and 3. So we're going to list out the zeros, and we're going to list out the values that are not included in the domain if perhaps we have a rational expression, right? Or inequality, I should say. And we're going to look to the left and right for the signs, right? So again, we're checking our expression against 0, right? So the values that are 0 and the values that are not in the domain are the values that we need as like checkpoints, right? So in between these values is positive or negative, and then we can start to build our interval for the solution based on those values. Okay, so let's go ahead and do an example. We're going to solve, graph, and write in interval notation each of the following inequalities. So for A, we have 1/4 x times x plus 4 is less than or equal to 1/2 times 3x plus 4. Now there are two ways to go about starting this. We can look at the LCM of 2 and 4 and clear the denominators, or we can go ahead and distribute first and then see what happens and then clear the denominators. So just to switch things up a little bit, we are going to go ahead and distribute first. Okay, so distributing this 1/4 x gives me 1/4 x squared plus x, since 4 and 1/4 cancels to 1. Here we'll have 3/2 x, and 1/2 and 4 reduces to 2. Okay. Now I can clear out my fractions. I can multiply everything by that LCM of 4. So here I will get a x squared of 4x. Here 4 over 2 will give me 2 times 3, so that'll be 6. And then 4 times 2 is 8. Now when I zero out my inequality, I can move things to either side. It doesn't really matter. However, it would be beneficial for me to keep x squared positive. Okay, I could move it over, and then when it's equal to 0, just change the sign on everything and I get the exact same thing, but that's kind of an extra step. So I'll go ahead and subtract my 6x and subtract my 8, and I have x squared minus 2x minus 8. So now I can start to solve for the zeros. Notice that 3 doesn't really apply to us because my domain for polynomial is all real numbers. There's nothing that I can't plug in. Okay, so when I get to 4 and I check my values, I just have to check the values between my zeros. So for here, I'm going to find the value. So hopefully this factors. If it does not factor, then we have to use the quadratic formula. Okay. So I'm looking for factors of 8 that add or subtract to -2. Luckily, we have two candidates at work. I can use -4 and +2. Okay. That'll give me a -2 when I add them together and a -8 when I multiply them. So the zeros are -2 and 4, right? The opposite values of what appears here. Okay. So I need to check in between those values. So when I say in between those values, I need to check on both sides, right? So I need to check for values that are less than -2 and then also larger than -2 but less than 4. And then I also have to check for values that are larger than 4. So I need to check values that are in between these things. So one here on this side, right, less than -2, in between -2 and 4, and one larger than 4. So I need 3 values to check. It's always easier to use values that are simple, okay? So the next whole number larger than 4 is 5. That would be way easier than checking 10 or 100 or something like that, right? Also, when I check these, it'll always be easier to use this form than the polynomial form, because plugging these things in, I don't actually have to find the values. I just need to look for the sign. So if I'm using x equals 5, well, 5 minus 4 is positive. 5 plus 2 is positive. I don't actually need the values. I just need to know if it's positive. So a positive times a positive gives me a positive, right? So now I need a value in between 4 and -2. The easiest one to use would be 0, okay? So if I come back to my factored form, 0 into both of these gives me a negative and a positive. So negative times positive is negative, okay? Next, I want to choose something less than -2, so the easiest would be -3, okay? It's the next whole number, next integer. So a negative and a negative is negative. -3 and 2 would give me another negative. So this would be a negative times a negative. Negative times negative is positive, okay? So at this point, I'm looking for things that are less than 0, okay, that satisfy this. So there's only one interval. It's all the values that are in between -2 and 4, because my check value, right, that works for this inequality is the value that is in between -2 and 4, right? So all the values that are less than -2 will give me positive values out. All the values that are more than 4 will give me positive values out. All of the values in between -2 and 4, including 0, which is my check value, will give me negatives out, okay? I can include the endpoints here because my inequality has an inclusion statement. It's things that are less than or equal to 0, right? Less than or equal to. So I'm allowed to keep the endpoints there of -2 and 4. Now, if it was a strictly less than, this would be an open bracket, open circle, and they would not be included in my interval. So my solution to this inequality are x values that are from -2 to 4, okay? This is the inequality that satisfies. Okay? So let's move on to the next example. We're going to talk about 1 minus 2x, over x plus 1 being greater than or equal to x over x plus 1. So here we have to follow things straight out. There's not too many simplifications we can do. We really need to just zero it out straight away, okay? So we're going to subtract this over, okay? We don't know if x or x plus 1 is positive or negative, so we're not going to clear the denominators, okay? That's why we're going to go ahead and just zero out our equation first, because if we clear out the denominators, that's going to change things quite a bit, and it's going to give us a bad answer. So pro tip here is when you have the rational inequalities, just zero it out, okay? Do not try to clear the denominators in these cases. So we need to solve without multiplying by factors of x, okay? Because again, if I clear out the denominator and I multiply times x plus 1 across everything, I'm going to end up with a lot of x squares going on, and that's going to kind of mess up my intuition of whether or not I'm using positives or negatives, because I have a square term there, right? Even though when I take the square roots, I get positive and negative values. That won't always be the case when I'm looking for things, for instance, that are not allowed in my domain, okay? I'm not allowed to have 0, I'm not allowed to have -1. So if I kind of clear these out, that takes care of the things that are not allowed in my domain, which is going to be an issue, right? Because I need to check across those values as well. So I'm going to subtract x over x plus 1, and then I am going to make note, first off, that 0 and -1 are not allowed in my domain, so those are two values of interest. But I also want to combine these to a common denominator, okay? So I'm going to have 1 minus 2x times x plus 1, because that's what this denominator is missing in order to have my LCM, okay? I'm going to add to that x times x plus 1, because my 1 is just going to be basically my LCM over my LCM. And I'm going to subtract x squared, okay? Because this is missing x in the denominator, so it needs an x over x term, okay? And that's my LCM. So that's what my simplified form looks like. Now, again, for the denominator, it's very clear. It's 0 and -1 are two values of interest. However, for my numerator, I have no idea what the zeros are for this thing. So I need to expand it and simplify it down, and hopefully I can factor it. And if I can't factor it, I'm going to use the quadratic formula on the numerator, okay? So first, let's multiply everything out. So I have these first four terms, which comes from multiplying out these two binomials, okay? Here I have my x squared plus x, and then my negative x squared, right? So from here, I'm going to combine like terms. I have an x squared minus x squared, so that cancels, and I'm left with negative 2x squared, okay? I have an x plus an x, that will cancel with this negative 2x. So I'm basically left with 1 minus 2x squared on top, okay? So if I need to, I can change the sign here since it's equal to 0 and change the direction, or I can just work with it as it is and set it equal to 0 and find out that this thing is only equal to 0 when 1 minus 2x squared is 0, which means x equals the square root of 1/2, okay, plus or minus. So those are my zeros. The values that are not allowed in my domain are 0 and -1. So those are the four values I have to look at. Positive square root 1/2, negative square root 1/2, 0, and -1. Okay, so let's go ahead and look at this. So we're going to use this reduced form. This reduced form when we check our signs. We'll look at what happens when we plug in values in between our checkpoint values in this reduced form, and whether or not they're positive or if they're negative and they satisfy this inequality. Okay, so that's what we're checking here. So again, our values of importance are x equals plus or minus square root 1/2, -1, and 0. X equals -2 implies to us, and again, this is my largest negative value, right? That's the most on the outside, okay? So looking at this, I will have -2, so that'll be -2 times a +2, so that'll be a -2 plus 1, so more negatives than positives, okay? And on the bottom, I'll have a negative times a negative, so that'll be positive. Negative and positive, that's less than 0, okay? -3/4, so that's in between -1 and negative square root of -2. So I'm kind of going from the negatives. If you're looking at a number line, I'm going along from the negatives to the positives in between my checkpoint values. So negative square root 1/2 is something around, it's very, very close to negative 3/4. It's a little bit less than that. It's like negative 0.72 or something like that. It repeats forever and forever, right? But somewhere around those values. So if I plug in negative 3/4, I end up with a negative over a negative, which is a positive value. It's larger than 0, okay? Because negative 3/4, that's negative, okay? And a negative 3/4 compared to 1, that will give me a positive and a negative is positive, so it's negative on the bottom, okay? Same thing on top. This is less than 1, right? So I have negative 2 times something less than 1, so that means that this is still larger than 1 and it's negative, so that's going to give me a negative on top. Okay. I'm going to use negative 1/2 because that is between negative square root, it's between negative 1 and 0, right? So that's the next value. Again, I'm just checking the signs. I don't have to do the actual math. So this will be negative, this will be positive, that's a negative, right? This will be negative 2 times a positive 1/2, right? So this will be negative, and then plus the 1. So that's actually going to give me a positive value on top. So I'll have positive over negative. So that's negative. And then for my last one, I'm on the other side of 0, but less than square root of 1/2. So that's positive over positive, which is positive. Then next is 1, which is larger than the square root of 1/2. And that will give me a negative over a positive, okay? So this will stay positive. This will give me a negative because negative 2 plus 1 gives me a negative value, all right? So I'm looking for all the things that are larger than 0, okay? So all of the positives are what I'm interested in. So this and this, right? So you can see I'm negative and then positive and then negative and then positive and then negative. So I need to figure out the interval, okay? So remember, this signifies that I'm in between negative 1 and negative square root 1/2, okay? This one, I'm in between 0 and square root 1/2. So those are the two intervals. Okay, so if I had to put it down here where I have my whole values 1, 2, 0, negative 1, negative 2, negative square root 1/2 is in between negative 1 and 0. Okay, square root 1/2 is in between 0 and 1. So it goes negative, positive, negative, positive, negative, right? So the negative portions are here, and this is strictly in equals to. Okay. Oh, it has the equality actually. Okay. So apologies. So, negative 1 and 0 are not included. Okay. The reason why they're not included in this interval is because they are not allowed in my domain, right? X and x plus 1. So 0 and negative 1 is not in my domain. So they cannot be included in the interval. It has to stay open since they're not included in the interval. However, this negative square root 1/2 and the square root 1/2, that has to do with the 0. So that's still included in the domain. So I can have a closed circle on those. So as a solution, okay, if I have not said this before, these little 3 dots, it means therefore, right? So here it was, therefore our values of importance are x equals these values. So I have it all plotted out on a number line. Therefore, my solution is x, any x value inside of the value negative 1 to negative square root 2/2. So this is the rationalized form of negative square root 1/2. Okay, or inside of the interval from 0 to to positive square root 2/2. 0 not being included, negative 1 not being included, but these square root symbols, values are included in my interval. Okay, leave this here for a second. All right, so the last thing that we're going to cover, okay, I believe the last example is this inequality. Okay, so when I want to solve inequalities, it's a little bit different. Okay, because remember, anything in here is positive. So I have to break it down to two cases, when the thing in here is positive and when the thing in here is negative. So before I take care of the two cases, I'm going to simplify and solve for the absolute value symbol. I'm going to simplify down and isolate my grouping symbol. Okay. So again, since anything inside the absolute value sign can represent a positive or negative value, we're going to split the inequality into two different inequalities, right? Without the absolute value sign. So based on the definition of absolute value, these are my two inequalities, right? So I have the positive one, right, which is just normal. And in the negative case, that means that the thing on the inside is now negative. So what that does is it changes the sign on my inequality, right? Because this thing can be positive or this whole thing can be negative, right? So I changed the sign on the right hand side and I changed the direction of my inequality, right? Everything else on the left side stays the same, however. Now you can think of this two ways. I could have simplified this and then did this switch, or I did it right at the beginning. It doesn't really matter. You'll get the same thing. So I'm going to work these things at the same time. So first things first is let's clear out these fractions, right? We hate fractions. The LCM of 3, 4, and 6 is 12. They all go into 12. So I multiply everything times 12. 12 over 3 is 4. 4 times 2 gives me 8, right? 12 over 6 is 2. 2 times 5 is 10. 12 over 4 is 3. 3 times 3 is 9. So if you notice, the 8, 10, and the 9 are the same on everything. The only thing that's different is the direction of the inequality and the sign on the right hand side. Okay. So now we solve this like normal. We try to isolate our variable. So we can do this several ways. We can distribute now if we want, but it doesn't matter because we still need to add this 10 over, right? So actually, since we're solving for 0, we move the 9 over, okay, in this case. So I'm going to add 9, subtract 9, and then this is what I have. I also distributed the 8 at the same time, right? Multitasking. Combine my like terms, okay? This is minus 5. This is going to be minus 23. And then I can move this back over, right? I probably should have just left it on the right side in the first place. So solving for x, we can add this to both sides and then divide by our 24. And so I have x is less than 23 over 24, which is almost 1. And x is larger than 5 over 24, which is less than 1. So these two intervals overlap each other, right? So together they actually cover the entire number line, okay? So my interval is basically all real numbers or from negative infinity to infinity, right? So here we have a list of properties for absolute values. Okay, so these are when we have single values. For us, we were in the case of 4. It just happened to be that the two values that we had were, one was, they were off skewed so that they overlapped, right? Which happens. So, you know, again, we didn't have a single absolute value. We had an equation, but this is just a property for inequalities as it relates to absolute value signs, so it can help you to kind of have some bearings, a little bit of a cheat sheet, right? All right, thanks you guys. I will see you on the next video.